All right. So we'll get started. I appreciate you taking time to join us today for this session about why you might consider a career teaching computer science and math. We have an agenda that is a little bit crowded, but actually not too bad. We're going to give most of the time to our two teacher guests. So let me just real quickly do some introductions. I'm Mark Ellis. I'm at Cal State Fullerton in secondary education, and I'm joined by my colleague from computer science.
I'm Doina Bain. I'm associate professor in computer science.
Great, welcome. And we're joined by two teachers from the local community. First is Stephen Kahn.
Hi, everybody.
And then Vicky Sedgwick.
Hi.
So you're going to hear a lot more from them in just a little bit. But we wanted to first have you think about where you want to be in the next 5 years, let's say, in this virtual ladder of life as we go from, oh my gosh, things are terrible, it can only get better, to, hey, I reached where I want to be, things are wonderful. Where do you want to be in 5 years? And you can quietly think about that. If you want to throw something in the chat, you can do that. And as you're thinking about that, I want to share with you some data about how a survey of professionals on where they stand on that ladder as they're in their career, where different professions landed. So what you'll notice is that second bar, the second highest bar, is teachers, K through 12. The only group that was higher were physicians. And so think about why it is that teachers rated their sort of satisfaction with life. Why did they rate that so highly? Why did they say they felt like their lives were in good shape and they were happy with what they were doing relative to many other professions? Any ideas you want to throw in the chat? Why would teachers be so satisfied? Okay, so the students, yeah, teaching the students, that's definitely part of it. Any other thoughts on that? Any other ideas? Yeah, good people. So their colleagues are there for similar reasons. Okay, so good. Here's a few more. So definitely the relationships with students and the learning that's happening. The work schedule was one that was big. They teachers work. I don't want to say they work a short day. They don't. But the teaching day is from 8 to 3, and you have time in the afternoons, evenings to do some planning, some grading. But in the summer, there is some downtime and some flexible time. You can continue your professional learning. You can take a break from things, spend time with family, friends, so forth. Teachers also said they like the challenge of the work. They didn't feel that they're bored. There's always something that's challenging them. Learning the content, just being a lifelong learner, was something that they reported as very positive. And then there's a certain degree of autonomy, meaning they felt like they can decide how they're going to approach the curriculum, how they're working with their students, how they best can support their learning. So while they maybe can't dictate the state standards, which are mandated by the state, how they actually implement curriculum and support student learning, there's a lot of flexibility and autonomy. So those were all characteristics that factored into this high rating of being very satisfied as a teacher. So now pivoting to this idea of computer science, we've known from a lot of surveys that have been done over the last 5 or 10 years that people want to see more computer science in school. 93% of parents have said they want their school teaching computer science, and yet less than half of high schools even have computer science options. 3/4 of Americans believe that computer science is cool, right? In a way that 10 years ago that wasn't the perception. So this idea of coding, I think, has caught on among the American public. And we know from data that students who learn computer science in high school are 6 times more likely to actually go on to major in computer science. And among women, they're 10 times more likely. So this speaks to the importance of amplifying our efforts to have more computer science courses, not only in high schools, but even in our middle schools and down in elementary, which you'll hear Vicky talk about in a little bit, what that might look like. Also, we know that computer science is a very growing field in terms of employment. So even though that small sliver on the left is the number of students in computer science classes in high school out of the total, so it's a very small percentage. But in terms of jobs, when you get out of high school and college, more than half of the jobs in STEM, in science, technology, engineering, math, are computer science related jobs. So it's critical that we increase the opportunities for students to engage with computer science earlier while they're in our K-12 school system. Now on the teaching side of it, why are we so concerned about preparing more teachers? Because we in California, and it's not that different in the rest of the country, but we have a lack of supply of teachers, particularly in math and science, and computer science falls under the umbrella of math and science. And you'll see over the last few years, we've actually been declining in the percentage of new teachers who are highly qualified. That means they've established the content matter proficiency and have gone through a state-approved credential program and become fully credentialed. So you see that number is actually declining. The graphs that are going up, the positive slope, if you want to call it that, those are substandard credentials, meaning they're earning credentials that are not fully credentialed. They might be an intern credential where they've completed some coursework, but not all the coursework, and yet they're teaching full time. Or they may even be teaching out of their content area. And so this is rather alarming. It's troubling to us, and it's also problematic if you think about the future of the kids who are in the classrooms with a teacher who is not yet fully credentialed. So we at Cal State Fullerton really want to raise awareness of the job opportunities and the real need that's out there for teachers of computer science along with math and science. I like this little quote, you know, a good teacher can inspire the mind, ignite the imagination, and instill a love of learning. That really is what the job is about. No matter your discipline, whether it's computer science or English or music, you know, you can think back and think of those teachers who really inspired you. They really knew their content, but they also cared about the students in their classrooms. So with that, I'm going to turn it over to Stephen to share with you some of his experiences as a teacher of math and computer science. It's all yours, Stephen.
Awesome. Well, hi, everybody. Thanks for tuning in. So my name is Stephen Kahn. I teach at Esperanza High School, which is part of Placentia Yorba Linda Unified. So most of our district is actually in Yorba Linda and Placentia, but we're the only campus in Anaheim, technically. Just a little background, I actually did my computer science bachelor's degree at Cal State Fullerton. And previously I worked as a programmer in IT. And Dr. Ellis was talking a lot about that, you know, job satisfaction as a teacher. And I can just say, by comparison, the job I'm in is the best job I've ever had, hands down. The trade-off on potential salary, I think, was 100% and then some worth it. That I you know, kind of just wanted to add to what Dr. Ellis had said about the work environment. I think one of the reasons why teaching is such a great job is that unlike a corporate environment where at the end it's kind of a competition of who's going to get the promotion or this or that, you know, we get paid based off of our education and our number of years working, and so it creates this less competitive environment and a more mutually supportive environment. I actually went back and did my FLM credential program at Cal State Fullerton as well when I decided to become a teacher, and then went and got I took the third CSET exam, if you're familiar with this. So I have my full math authorization. And then actually this was my job that I got directly out of school. So when they hired me to basically start the AP Computer Science program here. We had previously offered a class called Exploring Computer Science, which was basically just an entry-level class, but we added this class called AP Computer Science Principles, which even though it is AP, Advanced Placement, it is actually considered an entry-level introductory course. So over time, we turned that into our introduction. And so I've had this pleasure of being able to build our AP computer science program. So something I could say to, potential computer science teachers is that, if you become just a math teacher, now that said, being a math teacher is great. But you're going to probably be part of this big department. And I mean, there are plenty of schools with big computer science departments as well, but there is more potential to have a job like mine where you have autonomy, where I've really gotten that. I do more back and forth directly with administration. Not everything goes directly through our math department. I also have an additional credential in CTE, which is career and technical education. And I earned this after. I did this while I was working, and this allowed us to incorporate our classes into what they call a CTE pathway, which is a pretty big thing at the moment. Schools offering these pathways, and you get like a medallion and a certificate of completion if you do it. And the teachers that run these pathways have to have that additional credential. It also gives us access to extra funds. And so I feel like as a computer science teacher at my school, I am the only computer science teacher. I get that autonomy to build the program. The fact that I work here actually gives my school access to additional money. So in a lot of ways, I am adding a lot of value to my school that they wouldn't have without me. And I have amazing job security, because finding somebody that could replace me with my background and then what I've built here would not be easy for them necessarily. So while every teacher offers something unique, I think that being a computer science teacher, especially right now, puts you in a position to get a job where you can have autonomy, more of a back and forth directly with administration, and also the potential to add additional classes to be the architect of such things and all of that. So currently we offer a 2-year sequence that are both AP classes, and I'll go through those in just a second, like what they are specifically. Another thing I wanted to mention is that if you have no background in computer science, it's really not too much of a problem. When I got hired, they actually sent me to paid professional development. I got $1,000 to go spend a week at UCI actually, learning, and I went home in between. I wasn't staying overnight or anything, to go learn about how to teach the class. And a lot of these classes, they come with College Board, the company that runs AP, approved curriculum. And they make it really easy if you want it to be. Like, they literally give you day-to-day lesson plans and say, first 10 minutes, do this, second 20 minutes, do this. So you can, with no computer science background, get your credential, get authorized, go attend one of these professional developments, and you will feel capable of teaching this. I was still one of the only people there, probably the only person there with a degree in computer science, and I'm sure all the other people went on to teach a great class. My first year teaching CS principles, I did it exactly as the curriculum stated, and I had a 100% pass rate. And from that point forward, I've been modifying it, and I incorporated a lot of stuff from my college education. But long story short, you will have access to a lot of professional development, paid and otherwise, that will make being a computer science teacher highly doable, as well as grants that you can potentially get. And yeah, as Dr. Ellis pointed out in the chat, you could, when you get your math credential, you actually are authorized to teach computer science, although they actually have now, let's say, there's a teacher in our district that teaches biology, so she actually added a supplemental authorization in computer science. And then separate from that, CTE, when you get that credential, you choose a sub-track, and mine is technically in information and communications technology, and within that it's software systems. So and I was able to get that with some of my work experience signed off, but you can also get it through course completion and whatnot. Interestingly, if you have any background in computer science, so when I went to high school, which I graduated in 2005, so I'm getting up there, but they had a computer science A class already. So that was, if you've heard of AP computer science, that was probably the one that you've heard of, which is technically our second year class. And this is really designed to be like for computer science majors. The problem was kids were getting thrown into it and then didn't really know how to function. Keep in mind, like if you go into AP calculus, you had 11 years of math before you took that. So for your first computer science class to be this is a little bit tough. And so the year I actually started teaching the class, they created CS Principles. It was a brand new AP class designed to be entry level and a little bit more diverse to get, really to support the effort to get more women involved in computer science, a more diverse sampling of people from different backgrounds, cultural and otherwise. So now I gave you some decals around here. This is the curriculum I use to teach it. It's called UTeach right here, and it's developed by the University of Texas. It's a great curriculum. So if you wanted to teach CS Principles, I would highly recommend it. It's pretty high level, and they update it every year, which is great. They're not physical textbooks, so your school does have to pay a fee to use it each year, but the good news is that you're getting fresh curriculum every year. And then here's our logo up here. This is actually freshly created for our computer science pathway, the upper left, since you can't see my mouse. Now I wanted to, Dr. Ellis, did you want to go to the next slide? Awesome. So I wanted to kind of talk about some of the stuff we do in the class, because I could sit here all day and just say, hey, we offer this class, but I really wanted to give you an idea of what kinds of projects do we do in these classes. So one way that I introduce this, and anybody who's done computer sciences probably looks really familiar. My computer science teacher did this for our very first lesson, and so I continue the tradition. And the assignment is the students write down the directions for a robot, or sometimes you could say an alien as a variant, to make a peanut butter and jelly, or in this case, as you can see, a banana sandwich. And then it's hilarious because you basically just act it out. You do exactly what they say. And what it's really supposed to teach the students is that you have to be explicit with giving directions. Like if you tell the computer to do something, it's going to do that. So moral of the story, if your program doesn't work, you don't want to assume it's the computer acting up. It might just be it's doing exactly what you told it to do. You just didn't tell it what to do. So as like an example, people will say, open the peanut butter jar, but they're not explicit where they say, turn the peanut butter jar counterclockwise or something like that. So anyway, these pictures right here kind of tell the story of what you end up with. And I get really into it. I'll make a mess in my classroom and the kids laugh. And I've had students come and say they'll never forget this experience, kind of like when my first computer science teacher did it. So it leaves a lasting impact on the students. And I think it just sets the precedent at the beginning of the year, because then whenever we hit a snag like that, I can always say, well, it's just like the peanut butter and jelly sandwich, and they know what I'm talking about. We have more activities this leads into, of course, but yeah, I only had so much time. Could we go to the next slide? Awesome. So I wanted to give you like a little bit, I guess you could say this is a little drier, but kind of my sequence of programming assignments in the APCS Principles class. So I saw the question in the chat, which when we get to Q&A at the end, I could probably give you a better answer, but I would not call CS Principles an intro to computers in the sense that it is not a how to use a computer class. It is computer science. So maybe a distinction that should be made is that there's computer use classes, right? And then there's computer, and there is overlap, but computer science, I think, is more about putting yourself in a position of how the computer actually thinks rather than how to use the computer. So it truly is a computer science class through and through. It has programming. I'll go off of my slide for a moment and say that it's also sort of doubles as a digital social studies class or civics class, if you want to think of it that way. Consider if anybody saw Congress question Mark Zuckerberg, how illiterate most people are when it comes to computer science. And so this class is designed so that a student that's majoring in anything else could take this. In fact, an example that gets raised is that medical people need to know how to use technology and need to understand the way digital technology works, because they're going to be using digital tech to treat patients, and that's life and death. So it's a lot of looking at the impact computers have had on society, the social studies, and then looking at these different concepts through programming assignments. So for anyone that's worked with computer science before, it's usually got to start with the flowcharts. And believe it or not, this is actually where I first go off of my UTeach curriculum. I transferred from Saddleback College. So I actually take some curriculum that I did at Saddleback College and I morphed it. And this is what it is. So if you're familiar with programming, this is where I teach them if, else, for, while, sequencing instructions. Our first unit three of the terms that are on the AP exam is sequencing, selection, and iteration, or putting things in order, making choices like if and else, or iteration, which is repetition of instructions. So it's really to get them used to thinking about that. We go from there into the pseudocode assignment. So the AP exam has their own pseudocode. And the idea is that they basically just take their flowcharts and translate them. So I really try to sequence it so that if they did good job on those flowcharts and got the help they needed, it's just a translation into the next step. And then skipping, I'm going to skip Scratch for a moment. That introduction to C++ is the next step in that process where they take those same 8 programs and they translate them into C++ code. And so they're actually getting much more of the programming logic all kind of thrown at them at once. But because they're seeing it in so many different ways, it's almost like building literacy in multiple languages at once. And I think if you can see it from different angles, I think it usually leads to a deeper learning from what I've seen. Many of you are probably familiar with Scratch. So Scratch is a drag and drop programming language. They call it block programming, and it's really friendly for use like from anything from like elementary age all the way up to college age. People look at it from the get-go and initially think it's too simple, but really you could use it to do really complex programming. This is where I open up like more open-ended, creative stuff. They make games, and this is really take what you learned here and let's make something. And I don't put too many requirements on, except it needs to have at least this many levels or at least this many goals, that kind of stuff. So, and I go a little bit into game design theory too. I've done some game design classes too. From there, once they have done the intro, we move into a base converter, which is converting between binary, decimal, octal, and hex number bases. We move into search and sort algorithms, which I teach it a little differently than a lot of teachers. I introduce them to one search and one sort, and then the students are actually tasked with researching a search and a sort algorithm at least, and then they actually have to make a screencast where they explain how it works in addition to getting the code work. So I think that my teachers didn't have me do enough learning through research from programming, and so I introduced that to them. And then this last assignment you see in C++, this fun with arrays, is kind of all the training wheels are off, and can you code? It's like a shopping list program, to put it simply. And then this last part right here that I kind of chunked together, we do this language called processing, which is really fun. It's sort of Java light, which in the AP Computer Science A class, we code in Java. It reintroduces them to the audio and visual programming we did in Scratch, except now they're using math and actual programming statements to do it. So I'm really proud of this sequence. By the end, the students, I think, are more capable than a typical college student, even after 2 semesters of computer science. But of course, it varies by student, and it requires a lot of support on my side. I have to, be available for extra help on tutoring because I get students that are super advanced. I get students that are lower, and so computer science is one of those topics you got to be ready for a kid to show up with more knowledge than you, and you got to be ready for a kid to show up that you're going to have to hold their hand through the whole process. And yeah.
Right. Cool. Thank you so much for that window into your practice. And at this point, I think it's a good time to bring the question up that was asked about, well, isn't this creating barriers, having this all credential program, exams to get into teaching? And I just thought I'd ask you, Stephen, because you did come out of industry, right? You worked in industry for a little while, and then you transitioned into teaching, and you actually went through our foundational level math credential program as your initial credential, and then you've added on to that. So, do you feel like, why did I do all that? I could have just started teaching. I already knew programming.
No, content knowledge is one side of this. I mean, Dr. Ellis, you're already thinking this. So, but content knowledge is one side of this. And the other side of this is what we call pedagogy and teaching, which is the science of teaching. So I want you all to think about a teacher you had that was really smart, but really bad at teaching. There you go. Just because you know a subject doesn't make you good at teaching. And I dare say the credential program at Cal State Fullerton was probably one of the most enriching experiences of my entire life. It transformed who I am as a person. It connected me with fantastic people like Dr. Ellis here and plenty others. And it's, I would not be the kind of teacher I am today without it. It made me a stronger person. So no, I 100% believe in the gatekeeping in this instance, because I don't think having content knowledge is enough to be a good teacher.
Yeah, and I mean, I agree. It is a barrier, right? It is a barrier, but it's there for a reason, right?
It's because we want to have good teachers. We don't want to just have somebody that shows up and says, I know this subject. We want to have people that, I mean, really, the longer I teach, I'm even more fascinated by the science of teaching. It's almost like a neuroscience, the way your brain takes in information, how we think about things, how we problem solve. That's almost more interesting than what we're teaching. So I think to be a good teacher, it requires you to be a scientist of the science of teaching, not just of what you teach, so that you can really dig into the kids' brains and really say, why are they confused on this?
Yeah, Dr. Bain.
Yeah, so to add to Nafi's question, I don't know whether answer or not. So at the university level, there is not a distinction between being a private or public institution in terms of hiring. So if in order to get hired, you need to have PhD in computer science, a master in computer science. It does not make a difference. And the reason is that the students are more mature and the pedagogy does not play a role. So you graduate with a master in computer science, you can go ahead and you can teach. But when you teach little kids like elementary or middle and even high school, without this pedagogy, you will not be able to do well. So I really believe that having this pedagogy and maybe observing it over a period of time and improving it, constantly improving it, it's important. We have plenty of examples in my department in which we have excellent programmers, people from industry, and then their first semester is just awful. And they receive very bad student evaluations because they don't have that pedagogy and it's not being taught in computer science at all. The other thing is that when you look at why there are so many barriers for public education, it's that these barriers are there to make sure that everyone it's kind of equal. So there are no special rules. It's like starting a race. You need to have sneakers. You need to have socks. You need to have, I don't know, water bottle or the other. So everyone is equal. At the same time, when you have a private institution, they can set up their own rules. That's the reason they're a private institution. But being hired at a private institution, it's much less unified. So I don't think they will accept as freely as the public institution accept, because they don't require these credentials. So they may hire you part-time and they may keep you part-time forever, while a public institution, because of the credentials, everyone is equal. That's my 2 cents.
Yeah.
Yeah, I could add to that I think something that was said to me when I got my credential is, you are not just getting a degree, you are earning a professional certification, which, that can't necessarily be said about even a master's or a PhD, as great as they are as degrees. You're also getting recognition from the state of California that you are certified to do this. And I think there's a certain respect you get when you walk into teaching interviews, because they already, my admin doesn't really question our teaching techniques. They're like, well, you're professionals, you know what you're doing. So I think that there's something to be said about that. It's not just a degree; it's a professional certification.
Yeah. Thank you both for that. And we're going to pivot now to Vicky, and actually she can add to this, because I believe you also were in industry for a little while before you made the transition into teaching. So Vicky, it's all yours.
Yes, I was in industry for a while. As a child, I was sure I was going to be a teacher. Okay, so I did actually major in elementary ed in college. And when I graduated, there weren't a whole lot of jobs available. It was during the time when the market was like down for teachers. They didn't need teachers. And I actually moved. After college, I moved out to California, and my roommate had actually majored in computer science. I'm not sure if it was called computer science back then, because this was in the 70s, okay, the 1970s. And, but she majored in computer science, working on mainframe computers with punch cards, okay? And she got a job at a company that needed computer operators, and that was my first job as I was thinking about, do I want to try and get a teaching job, even though the market is really bad? And I kind of fell in love with computers, and we transitioned our workplace at that point from mini computers into a mainframe computer, and all the programmers, of course, wanted to work on the new mainframe. They didn't want to work on the mini computers, which was actually running the business. So I taught myself to program, to troubleshoot when our customers had problems. And that transitioned into a career as a programmer and systems analyst for about 19 years. It was between 18 and 19 years where I did that. And I was writing, designing and writing application software for all kinds of different kinds of industry. And then I had kids, and I became a stay-at-home mom and worked as a web designer. This was in the earlier days of the internet. This was early 1990s. And I did a lot of different web design from my house. So I still love to teach. And in fact, in my industry job, I would teach adults how to use our software that we created. And a lot of times we worked with salespeople, and I was in charge of training all the salespeople on the software. So I created courses and how they could learn to use our software so they could sell it and stuff. And so I'd never totally gotten away from the idea of teaching, but I was teaching adults. But 13 years ago, at my daughter's school, and I actually am a private school teacher, and she was at a private school, I was asked to take over the computer classes. I had helped somewhat with the computer classes there, and when the person left, they told my principal, "You must hire Vicki." And at the time, I wasn't sure I wanted to actually go back to work full-time. So I took it temporarily. And 13 years later, I'm still teaching because it's an awesome job. I mean, it is amazing to watch kids go from knowing nothing to being pretty proficient in programming, even in the K-8 space. When I took over the courses, they were applications courses. They were, let's teach you how to use Office, or let's teach you how to type. And I personally didn't want to stand in a class for 45 minutes and watch kids type. I found that pretty boring. And so I decided I would figure out what kids could know about CS. And this was, I taught K-8 at that school. And so I actually at the time found the Computer Science Teachers Association standards. That was before, way before California had computer science standards, and discovered Scratch and started adding computer science to the curriculum. I had already taught some things about computing systems, about inputs and outputs and names of the parts of the computers and things like that. But I started adding programming to my courses. So it was a lot of fun, and it was great to see the kids kind of get it. Okay, I started with my middle schoolers and then moved it down every year. I'm currently at a different school, and it's still a private school, and I teach K-6 right now. And I'm actually now a CS teacher officially. I don't teach applications that much anymore, though this year, because we're virtual and we went one-to-one, all of our kids had to learn more tech more quickly than they've learned in the past. So we did some tech classes, but mostly what we do is computer science. I'm also on the Computer Science Teachers Association board as one of the K-8 representatives. And I actually helped to write the 2017 version of the CSTA standards. And those are the standards that the California standards were based on. And I've also helped write the teacher standards, so standards for computer science teachers. I helped to write those as well. So I'm kind of involved in the K-8 community of computer science teachers now. We'll answer that question in a minute. So middle school and elementary. What does middle school CS look like? Well, this is a bunch of pictures. And if you click on the pictures on the slides you got, it'll take you kind of to what the curriculum or what the thing is they're doing. A couple of them will take you to reflections from my students about what they were doing. But there's all kinds of different things that we've done in our CS classes. On the top left is the three girls are working on defining what makes a computer a computer. This is from the Computer Science Discoveries curriculum from code.org. And one of the first things they do is have kids decide what is a computer, what makes a computer a computer. And so they're working on deciding, is it a computer, is it not computer? And with middle schoolers, you can get in some very interesting discussions on why they think something's a computer or not a computer. So that's the start of that. And I used that curriculum a lot in middle school. But we also used, if you continue on the top, Scratch, especially at the beginning. That was where we first started. It's a great visual thing. And it's easy. It's what we call a low floor but a high ceiling, because you can get started very easily. And they don't have to worry about syntax, yet they can create some pretty complex programs, and they can learn the concepts of sequencing, of algorithms, they can learn the concepts of conditional logic and loops and all kinds of things. So that one's Scratch. We also got into, in my middle school, into some actual languages with syntax. We did some Python work and some JavaScript work. And these are three boys are working in a program called Pencil Code, and it's an online program that lets you do, it's a JavaScript-like language. One of the most enjoyable things is physical computing. Nothing beats seeing a light blink. You know, so much different than a Hello World program, right? You can write a program that says Hello World, and that's cool. But making a light blink is so much better. And yet it's Hello World in physical computing. So we did a lot of different physical computing. We've used Makey-Makeys in elementary and middle school. Microbits, which is a little micro controller that you can program. And in fact, in the UK, they gave them out to all of their 6th graders. And then Arduinos in 8th grade, we got into Arduinos. So that's the physical computing part. Again, this is Scratch. This is somebody using Python. Again, we also did a little bit with app development. We've used MIT App Inventor a little bit, which writes Android apps. Kids want to write apps. It's difficult to write, and they want to write iPhone apps because they have iPhones, but those are very, very difficult and costly because you have to have a developer account, and you have to know Swift and Xcode and all of that. So we typically did things that were simpler. We did MIT App Inventor, which is also a block-based, and it works only on Android. And we did something called App Lab at code.org, and those create web apps. So basically, it's really HTML and JavaScript, but it looks like an app when you put it on your phone. You can add it to your home screen, and it's cool. So we did that, which is very fun. And we do things that are unplugged. like that peanut butter and jelly. We do that kind of thing as well. So in elementary and middle, there's a lot of peanut butter allergies. So typically it's a jelly sandwich, not a peanut butter and jelly sandwich, because I can't use peanut butter anymore. But we do the similar kind of thing. And this one is also emphasizing that same kind of concept of having to, whatever you tell them they're going to do. I give each kid a set of like 5 Legos, and they turn back to back. One of them creates something with those Legos, or identical Legos, and has to tell the other one how to make it exactly like they do. And you can also do it as a written thing, but we do it back to back. And then they turn around and see, did they make the same thing? Right. So it's, can I give clear enough instructions that somebody can make it? And even with 5 Legos, it usually fails because we're not explicit enough to begin with. So that's kind of basically what it can look like. Now, I taught as a in a lab as a dedicated teacher. It can also, though, be in a classroom, and it often is, and we're going to talk about that when we get to curriculum. So, elementary CS. And yes, even kindergarteners can learn CS concepts. They can start learning the terminology. They, especially in K through 2, teaching sequencing can be really helpful in a lot of cases because it's also very valuable in math. It's very valuable in literacy and learning to read. So getting them to understand sequencing and that things happen in order, recognizing patterns in things to know when a loop is supposed to happen, can also tie very much to their math curriculum, or can tie into using literacy and things. In literacy, I've done things, these upper ones at the corner up there with the kids with holding the picture and the paper computer. Those are actually books, and they're Hello Ruby books, and they're books that are written specifically to teach concepts of computer science. This one teaches about what a computer and what's inside a computer and how they kind of work, and they actually make the paper computer. There's also ones that teach basically what an algorithm is, what sequence is, what a conditional is, and that's what the map one is. They create a map. We use a map of the school, and they go on a treasure hunt because that's what happens in the book, and we actually go out and physically move around, lots of that. So we do that. We often do dancing. Dancing's a great way to teach loops, right? Because dances often have loops in them. So we do a lot of dancing in class. We like to get the kids up and moving, especially in elementary. Hands-on and moving is really important. Doesn't have to be sitting in front of a device. We also use robots. See robots at the top ones. There's 4 different ones. I have used a bunch of different ones. Our current school uses Ozobots, which are tiny little computers. It can be anything from just a pure line following robot where you draw lines and you control it just with lines, or you can actually code it with block coding, like a Scratch kind of coding. Up through, we do Lego robotics in our 5th grade. But I've used Sphero robots. They're round little robots. They look like balls, but you can program them. They're very cool because they're also kind of waterproof, so you can do things in water, or you can paint with them or things. But in this case, these are a 1st grade class that's just exploring what they do and how they move. They're using some block-based to just do simple sequential algorithms to have them try and knock down the bowling pins, right? I've used them in older grades where we've actually explored the relationship of speed, distance, and time with those robots, because you can control the speed, you can control the distance, you can control the time that it works. And so they can start to do predictions on how far something's going to move based on how fast it's going or how long it's going for. Our Lego robotics program ties into our 5th graders work and talk about Mars, and they talk about colonizing Mars and things, and which has been great this year with the rover just landing. It's been awesome. But they then make a project with Lego robotics, having a robot that can do something on Mars. So, and they give presentations on that and things. We've also used the dash and dot robots. Those are kind of fun. Again, all of these have block programming abilities. So they're pretty accessible from a programming point of view, and they get the kids hands-on with using robots. And then this is at our primary level. We use a robot called Bebot. This is actually the blue bot. It's hard to see it, but it's a see-through robot, so you can see the inside of it. And all you program that with is just arrows. They just press arrows on the robot, okay, and go with that, okay. But it can tie to any curricular area. If you see this one, it's tying to language arts. They're matching either the name of something they draw on, and they draw a card with the name of something and they program to that. So lots of different options at elementary. Again, if you click on the pictures from the slides, you can actually go to and see what the curriculum is behind it. You quickly go to the next. I'm not going to go into detail on this, but California does have standards, and if you click on this picture or go to the QR code or the bit.ly, you can see the standards, California standards. That's kind of what you should teach. How you teach it depends on the curriculum you use. If we go to the next one really quickly, there's tons of curriculum out there. Some is more robust than others. All the ones that I've listed are free curriculum, okay? There's tons that are paid. There's some that's paid also. These are all free curriculum. If you're interested in math and science tying into CS in elementary or middle school, Canon Lab has something called Action Fractions, which is a curriculum for teaching fractions along with teaching Scratch programming. So that's a great one to look at. And if you're in middle school, Project Guts is CS in science. It's modeling science phenomena with coding, and it ties right into the middle school science curriculum. And Bootstrap Algebra, if you teach algebra at 8th grade, for example, 7th or 8th grade, Bootstrap Algebra can be used to teach algebra along with teaching computer programming. So there's a lot of options. If you click on any of those links, it goes to all that curriculum.
Wow. Awesome. Thank you, Vicki. And I agree with what Nafis has said. It seems like you're having a lot of fun.
It's awesome. I mean, that's the thing, is you get to have tons of fun.
So if you have questions, put them in the chat, and we'll get to those in a second. I just want to share a couple of slides with some information about our credential programs and some of the support we have. So for the program that Stephen went through, the foundational level math program, it does require a bachelor's degree. That's a requirement in California. And then the post-baccalaureate is the credential program. There are 4 prerequisite courses. You can see them there: EDSC 310, 20, 30, 40. There is a educational technology proficiency recommendation. If you have a CS degree, that's probably going to be waived. We do have subject matter exams if you did not complete a course sequence in mathematics, for example. You take the CSET exam in mathematics, and that will establish your proficiency. So you can learn more about that on our programs page. We also do have funding available. The Math Science Teacher Initiative, MISTI, which is funding this webinar. We have scholarships that we award. Last year, we awarded $56,000 to students who are earning credentials in math or science. We've added this year a CS scholarship for anyone who's a major or a minor in CS and is working toward a foundational level math or math credential. You can apply for a scholarship. There are also some federal grants that you should investigate if you're considering going into teaching, so check that out. And then new, we also have pathways if you're thinking of multiple subject teaching, so that would be elementary, getting a credential in multiple subject, and you would add authorization to teach computer science. We have some pathways that we've designed along with computer science department, a minor, and the bachelor's in child adolescent development or in liberal studies. So we've created these combined pathways that would bring all of that together. So if you're interested in that, check that out. And then finally, what Stephen was sharing earlier, once you have a credential, there are opportunities to go through some additional coursework to add authorization. We do not have it at Fullerton, but they have developed a pathway at CSU Bakersfield that is open to applications for this summer. And also San Francisco State University, along with SF Unified, created a CS in SF program that I've put the flyer there for. So with that, we have a couple minutes if there are any questions, and I believe Dr. Bain put in the chat that we'd love for you to complete an exit survey. So please be sure to do that.
If you want more information regarding the scholarship, which will be it's due and awarded this semester, please contact either me or Dr. Ellis. You have our email addresses.